Okay, this is Tony George. I'm the coordinator for the IOTA R-OTE volunteer group. And in this session, our second training session, we are going to demonstrate a new version of R-OTE, R-OTE 4.5.9. And we're going to analyze a file contributed by Ted Swift in our group, which contains an integrated video CSV file and some interesting characteristics that we can show in our R-OTE analysis. So I'm starting with RStudio open. We're going to load the version of R-OTE by setting the working directory. So we choose the directory, and the directory that we're going to use is R-OTE 4.5.9. It has some improvements to error bar analysis and some other minor improvements. And so we're going to select this folder. And after we select the folder, we see that the contents of the folder are displayed here. And we want to select the UI.R code, which is the user interface code that we use to initiate R-OTE in RStudio. And once that code is displayed in the box, we're going to press Run App. Run App initiates the Google Chrome graphic user interface. So this is Google Chrome initiating, and this is our normal starting screen in Google Chrome. You can use Internet Explorer too. They're interchangeable. So our first step is to select a file, and we press the button. Our file Internet Explorer box opens up, and I've got it already set to the Ted Swift example file of Polyxo, recorded on November 12th, 2016. And we'll open this file, and we see a occultation light curve. We want to see if there's any secondary star light curves in this CSV file, so we press this Show Secondary Light Curve button, and sure enough there is. And the secondary light curve shows that there's some attenuation of brightness due to atmospheric extinction, maybe a cloud or something that has affected the light curve. So we'll end up analyzing this light curve by normalizing it to the secondary light curve. So the first thing what we want to do after loading the file is we'll look at the basic files that we received on this particular event. Typically we'll have a path map. Here's our path map. It shows a magnitude drop of 1.0. We'll consider that in our analysis. We have the original observer report, which is done in an Excel spreadsheet format, and we see in this report that the observer used a PC-165 DNR camera. It was an NTSC format, and it was operated at an integration of 4x fields, or 2 frames. There's 2 fields per frame. We'll look at the camera delay correction and the VTI correction, and we'll verify those as we proceed with our analysis. This observer also produced an AOTA report, and in that report he gives us the DNR times for the event and some error bars. It indicates that it is an NTSC camera, and he's applied the delays appropriate in AOTA. We may return to that part of the report as well. And then we have the light curve, which we've already opened up. This is a iMovie file format light curve. Okay, so after we've loaded the light curve, we can check to see if there's another secondary star that maybe even has a better light curve, and that's done in this secondary data column. We see that the primary is already loaded. That definitely is an occultation event. So we'll leave the primary loaded in column 11. But let's look in column 13 for another secondary star. That one's blank. So there was only one other secondary star analyzed in this analysis in iMovie. Our next step would be to go to process timestamps. And we hear a little bell click, and that tells us that there may be a window that's appeared behind our Google Chrome screen. So I'm going to press Alt-Tab, and that brings that window to the front. And that window says that the file must be in R-OTE format before timestamps can be processed. So the first thing I do is write the file in R-OTE format. And down below here in our RStudio screen, we can see that we wrote the file in R-OTE format. So now I can go to process timestamps. And on this menu we see that we have a video type of NTSC already checked. That's the type we want. Our time delta is entered for that type. So now we need to enter our camera delay and our VTI offset, if appropriate, into our menu items. So how do we determine that? Well, we're going to go to the original user report that we get from the observer. So we have all of the original user report files filled in. And we can go to the corrections tab at the bottom, and we can look for the camera that's in use, the PC165 DNR, and it's operating at 4x. So the delay for an EIA or an NTSC camera is a minus 0.0667 seconds. So we'll click on that and copy it, and then we'll return to our R-OTE page and we'll paste it. And then we want to look for the VTI offset. That's also on the corrections page. It's in this little yellow goldenrod colored box, and it shows that depending on the type of video time inserter used and the software used for the analysis, you should either apply no additional correction or a minus 0.1667 second adjustment. So if we go to our data table, we see that the timing device was a Kiwi OSD, and the Kiwi OSD, and we're using R-OTE for the analysis, so we're going to apply this minus 0.01667 correction. So we're going to copy that, and we'll go back to our R-OTE page, and we'll paste it. So now we've got our corrections. Next we'll look and see if there's any VTI timestamp issues in this file. So we press the plot VTI analysis, and another screen has popped up. We can find that by going Alt Tab and pop it up that way, or since it's behind the Google Chrome, we can also look down here on the taskbar and see that it's popped up. So either way we can find that screen. And it's found no OCR errors. Well, it found OCR errors, 10 of them, and corrected them, and it's found no missing frames. So we have a fairly valid sequence of timestamps, so we can proceed with validating the timestamp. To validate the timestamp, we select the first frame in the file, and then we select the last frame. We can do that because by looking at the number of frames is less than 1500. So if I put 2000 into this box, it clicks onto the last frame, and then we're going to look at the span of these frames and see if the timestamps agree with the frame rate. And we do that by clicking this button, Validate Time Span. And R-OTE says that all of the frames are valid, and so now we can add this valid timestamp to the very first frame. All we have to do is change the date to conform to the date on the file, which is 2016 November 12th. So we go 2016 11/12. And then we add that information to the file comments. And that appends our corrections and our timestamp information to the file.